Hi, Miss Marion here. Let's go ahead and turn to page 135. We are going to read an I can statement for today. I can compare proportional relationships represented in different ways. Go ahead and write a sentence on how you feel about that right now. I'll also give you a number. 1, I don't remember. 2, I kind of remember. 3, I remember, but don't ask me to teach it. And then 4, I do know it, and I could teach it to my friend. Go ahead and do a sentence and a number. Let's go ahead and let's turn to page 37. On page 37, it says the equation y equals 4.2x could represent a variety of different situations. Write a description of the situation represented by this equation. So write a story. Decide what quantities x and y represent in your situation. So figure out what the x means, what the y means, and then you're going to make a table and then you're going to make a graph. So you need to go ahead and pause right now. Go ahead and do that. All right, here are some examples of both the graph. So I have a table. I used the y equals 4x. I put in 3 and I got 1260. I put in 4, I got 1680. And then here is my graph that I went ahead. On the bottoms, I went by ones. And then going up and down, it is labeled as the 2, 4, 6, 8, 10, kind of along in there. And then my graph went along here. See how this is 4, 1680, 4, 1680. And then here's also another one. My story was that it was cost of movie tickets. So the number of movie tickets was going up and down as far as the x-axis. And then the y-axis is the amount of money that I would receive. Notice I put 0 in for the equation. Then I put 1, what was 420. I put in 2, 840. And then I can also put in 3. And so this is my story that went along with this situation. All right, let's go ahead and turn to page 38. On page 38, we have this example. Elena babysits her neighbor's children. Her earnings are given by the equation y equals 8.40x, where x represents the number of hours she worked, and y represents the amount of money she earned. Jada earned $7 per hour mowing her neighbor's lawn. Who makes more money after 12 hours? How much more did they make? Explain how you know. And then B, what is the rate of change for each situation and what does it mean? And then C, how long would it take each person to earn $150? Go ahead and pause and work through that. Remember that you're both talking about Elena and then you're also talking about Jada. All right, let's go ahead and go through this. And so let's look at each person individually. So again, Elena, her equation was y equals 8.40x. And so remember that 8.40 is the rate of change. It's technically 8.0. So Elena, and it's 8.40 over 1, okay? And so it changes, so it's $8.40 for 1 hour is how she actually goes. And so that's what she makes. And then we need to figure out Jada. It says Jada, she earns $7 for 1 hour mowing her neighbor's lawn. So Jada, she is $7 for 1 hour. Okay, and so what we want to do is we want to go ahead and we want to find out who makes more when it's 12 hours, right? And so for Elena, we can go ahead and take $8.40 and multiply it by 12. So grab a calculator. Let's go ahead and do that. So 840 times 12. It's $100.80. Okay. Let's do Jada. Jada, let's do $7 times 12. That is $84. Okay. So just looking at this, who actually makes more money? Well, that's going to be Elena. She makes $100.80. Jada makes $84. And then how much more does that person make? So we want to go ahead and figure out how much more Elena makes. Let's do 100.80 minus the 84 that Jada makes. And she makes $16.80 more. So $16.80 more. Okay. And then for B, what is the rate of change for each situation? So again, the rate of change is where we have the denominator having the number 1. So Elena's rate of change is $8.40 per hour. Jada is $7 for 1 hour. And what does this mean? So Elena, for every hour that she works, she makes $8.40. For Jada, for every hour that she works, she makes $7. And then how long would it take for each person to earn $150? So let's think about it. Let's go back to Elena's equation. Elena's equation was y equals 8 point. For some reason, my pen's not working today. So her equation was y equals 8.40x. And then if we put Jada's together, Jada's, remember that this number is the k value, or it's the rate of change, or it's a constant rate of proportionality. So hers is actually going to be the $7. So let's make an equation for Jada just really quickly, and I'll show you in a second the reason why. So we have Jada. Her equation is y equals $7 times x, and this one over here is Elena. Okay, and so the question is how long would it take for each person to do $150? So that's the end result. That's the money. And as we can look before, as far as especially with Elena's, is that y represented the money. So we're going to take the 150 and we're going to put it into the y situation in the y part of the equation for everyone. And then we're going to solve it and see how long it takes. So we're going to do 150, 840x. We're going to divide by 840. So 150 divided by 840. And we have about 17.9 is what we have. And usually when you are working, you usually do it by how many hours. So we're going to say Elena actually does 18 hours. And then let's do the same thing for Jada. We're going to do 150, 7, and we're going to divide it by the 7. So 150 divided by 7. And that's about 21.4. Okay. And if you look at it, can Jada just do 21 hours to be able to make the 150? That's no. So we actually have to round hers up also. So hers is going to be 22 hours. All right, number 2. Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table, so hers is over here, okay? Han's is $15 for every 300 envelopes he finishes. Who would make more money after stuffing 1,500 envelopes? How much more money would they make, and explain how we know? What is the rate of change for each situation, and what does it mean? And then who gets paid more in their job, and explain why. Go ahead and pause right now and go ahead and work through that, and then we'll actually work through it together. All right, now since you've worked through it, let's go ahead and go through it ourselves. First of all, let's kind of look and see. We have number of envelopes, and then we have dollars. We need to find an independent and dependent variable. And the reason for that is we want to go ahead and write the equation, the y equals kx equation. And this will actually help us so much easier to go ahead and answer these. So think about it. Is it the number of envelopes depends on the money? Or does the money depend on how many envelopes you stuff? And so the money is the dependent, and the envelopes is the independent. And as definition wise, independent is always x, dependent is always y. So let's go ahead and look through it. So Claire is the table. Remember yesterday we actually would pick a point, and I'm going to do Claire as blue. So we're going to take this point, and remember how we did a y over x equals our vertical over horizontal. Same thing. Remember, this is a proportional relationship. Always starts at 0, 0, and then our point is 400 and then 40. And so let's fill in the equation. So we have y, x. So our vertical, if we look at this triangle, our vertical is going to be 40. So let's go ahead and label that. So vertical is 40. And then horizontal is 400. And then let's go ahead, let's cross multiply and divide. So we have 400 y, 40 x. We're going to divide by 400. And then so y, because 400 divided by 400 is 1, it leaves y by himself. And then we have 40 over 400. Let's put that into our calculators. Let's reduce that down as much as possible. And that would be 1 over 10x. So this one is Claire's, okay? And then now let's talk about Han. So Han, his point, so we have pretty much this point is 300, 15 if we're following the same format as far as the table. And then again, we can go ahead, and I'm going to do this in a different color. We have the triangle, starts at 0, 0. This point up here is 300, 15. So we have y, x, vertical, horizontal. So it's y, x. Our vertical going up and down is going to be 15. Horizontal is going to be 300. Cross multiply and divide. So we have 15x, 300y divided by 300. So take the 15 over 300. We're going to go ahead and simplify it as much as possible. And that ends up being 1 over 20 x equals our y. So we made the y equals kx equation for both of these. And so the reason why I went ahead and did that is because we have to find out, after stuffing 1,500 envelopes, which person makes more. And so the envelopes is here. We're going to stick it into our equation, and then we're going to find out the y, which is the amount of money-wise. So let's start with Claire. So Claire, her equation is y equals 1 over 10 x, and then we have, so we're going to take 1 over 10, multiply by 1,500. So 1,500 times 1 over 10. And then her amount is going to be $150. Let's go ahead and do Han. And Han, his is in blue. So we have y equals 1 over 20x. Put in the 1,500, and they are multiplying. And stick it in your calculator. Press enter. And he is going to make $75. So who makes more? So Claire makes more. And if we want to find out how much more money, we are going to go ahead and take the 150 minus off 75. Sorry, that was 75. Let's erase that and change that. And she makes $75 more. And then what is the rate of change for each of the situations? We've kind of already talked about that. So Claire's rate of change is actually this K number. So hers is 1 over 10. And I'm actually going to go ahead and label it because we need to talk about what it means. So we have 1 over 10. And we have it as far as the rate of change itself. And what does that actually mean? So for every 10 envelopes, she gets $1. Because remember, it's the y over x is what we're working with. And then let's look at Han. Han kind of same scenario as far as labeling it. He gets $1 for every 20 envelopes that he stuffs. And these are what are the rate of change. So who gets paid more in their job? Well, let's kind of look at it. So Claire, she only has to do 10 envelopes and she gets $1. Han has to do 20 envelopes and he only gets $1. So who makes more? Well, Claire actually makes more. And this is kind of the reason why. All right, let's go ahead and turn to page 39. And we're going to look at problem number 3. Tyler plans to start a lemonade stand and is trying to perfect his recipe for lemonade. He wants to make sure his recipes don't use too much lemonade mix, which is lemon juice and sugar, but still tastes good. Recipe number 1, so I'm going to underline that, is given by the equation y equals 4x, where x represents the number of lemonade mix in cups, and then y represents the water in cups. Lemonade 2 is given by the table. And then if Tyler had 16 cups of lemonade mix, how many cups of water would he need for each recipe? What is the rate of change for each situation, and what does it mean? And then Tyler has a 5-gallon jug, which holds 80 cups to use for his lemonade stand, and 16 cups of lemonade. Which lemonade recipe would he use? So let's go ahead and let's start it. So number 1, we already have the equation y equals 4x, right? And so that was given to us. Number 2 is the table. Let's go ahead and figure out an equation for the table and then go from there as far as answering the questions. All right, let's do the equation for number 2. Number 2, so this is my point. And then again, as far as trying to figure out, they already told us the x is the lemonade. So this is our x. Y is the number of cups. And that was given to us kind of with the information above. And so remember, we are going to do y over x, vertical over horizontal. So if we did our triangle, it's 0, 0. Top point is going to be 10, 50. So our vertical would be 50, horizontal would be 10, and then we would cross multiply and divide, and then we can find an equation for the second lemonade stuff. So we're going to do 10 times y, 10y. 50 times x is 50x. We're going to divide by 10. So our equation is 5x equals y, and this is the number 2. Okay? And so let's kind of talk about it as far as we can actually do the rate of change kind of stuff first. So for number 2, our rate of change is 5 or 5 over 1. And if you label it, it will be 5 cups of water for 1 cup lemonade mix. So that is number 2. Let's look at number 1. They already had the equation y equals 4x, so the rate of change is 4. And let's go ahead and label it. So this is cups of water is the 4, and then 1 is the cups of lemonade. Okay, and so that kind of tells us as far as what's going on with the cups of waters versus cups of lemonade for both recipes. So the red is recipe number 1, green is number 2. So let's bounce back up and let's do A. If Tyler had 16 cups of lemonade mix, how many cups of water will he need? And so we can actually put it into the equation. So let's do number 1 first. So our equation is y equals 4x. So we have 16 cups of lemonade mix. And lemonade mix, if we remember, is our x. So we're going to go ahead and put it in for our x. So we're going to have it as 4 times 16. So grab a calculator. Let's do 4 times 16. We get 64. And what does that mean? That means it's 64 cups of water. Sorry, my pen is not working very well. All right, let's go ahead and let's do number 2, same kind of thing. So we have y equals, and that equation was y equals 5x. So we're going to have 5 times 16. So if we do 5 times 16, that amount is, so it's 80. So it's 80 cups of water. So lemonade number 2 uses more water than lemonade mix number 1. Last one is Tyler has a 5-gallon jug which holds 80 cups to use for his lemonade stand, and he has 16 cups of lemonade. Which lemonade recipe should he use, and explain why? If we look at the answers above, so with recipe number 1, we have 64 cups of lemonade. For recipe number 2, we had 80 cups of lemonade. So can this 5-gallon jug hold a recipe number 1 and recipe number 2? That answer is yes. Honestly, it really kind of depends on what we want to do and what we want to kind of have as far as the end result. And so as far as, do we want to be able to go ahead and make some lemonade with recipe number 1 and have some left over for the next day, or do we want to do recipe number 2 and kind of keep it the way as far as what it's there? And so it actually kind of just depends back and forth. All right, so what we've been doing for the last little while is we've been going through these different problems and comparing proportional relationships, and we're comparing the constant proportionality or that rate of change with all these different situations. So if we look at it, number 1, we were looking at an equation and a table. Pretty much a lot of them we've been working at either a situation or a table or an equation. So there's different ways of actually looking at all of these. So that was our goal for today. And so we need to go ahead and have the K value or the constant proportionality to go ahead and compare those together. And so we want to, and then also when we have that number, we want to go ahead and we make sure that we label our fraction as far as the top and bottom so we know what's going on. Go back and back to page 135 and go read the I can statement. I can compare proportional relationships represented in different ways. That's what we were doing. Give yourself a number. So I don't get it is number 1. I kind of get it is number 2. 3, I got it. And then 4, I can teach it to my friend. And so give yourself a sentence about how you feel about the I can statement and give yourself a number. Make sure you go ahead and do the practice problems for today. They are in Canvas, and so make sure you go ahead and do those and have a good day. Thanks. Bye.